today's lesson, we'll use pedigrees to decipher and predict the inheritance patterns of genes. Our objective for today is to be able to predict patterns of inheritance based on pedigree analysis. So that's what you should be able to do by the end of this lesson. Our vocabulary for this lesson includes pedigree, sex-linked traits, and carrier. People want to know things about the future, such as what is the likelihood that I'll have a child with a particular genetic disease, say hemophilia? Or what's my own risk of developing a genetic disease, such as Huntington's disease, later in my life? Well, geneticists who study these and other diseases want to know other things. How is a particular disease or trait inherited? Or is it recessive or dominant? Is it carried on the sex chromosomes or on one of the other chromosomes? A pedigree is a type of family tree that can help answer these questions. Dog and horse breeders often speak of pedigreed animals, a feature that adds tremendous value to the animals. This is because with knowledge of an animal's family tree or complete lineage, it is much less likely that any genetic surprises will occur as the animal develops and reproduces. In a pedigree, information is gathered from as many related individuals as possible across multiple generations. You can see a chart showing that in Figure 716, displayed here in the video. Starting from the bottom, each row in the chart represents a generation listing all of the children in their order of birth, their sex, and whether or not they have a particular trait. Working up the pedigree, the children's parents are indicated, and above them, their parents, for as far back as data are available. Now, squares represent the males, and the circles always represent females, and these shapes are shaded to indicate whether or not the individual exhibits the trait of interest. Sometimes the genotype, as much of it as is known, is also listed for each individual. By analyzing which individuals manifest the trait and which don't, it may be possible to deduce a pattern of inheritance for the trait, or at least rule out certain patterns. For example, for dominant traits, all affected individuals must have at least one parent who exhibits the trait. In contrast, for recessive traits, an individual can exhibit a recessive trait even if both parents are unaffected, or, for example, don't exhibit the trait. And in this case, the individual's parents must be then heterozygous for that trait, where each one is carrying one dominant and one recessive allele. Whether a trait is carried on the sex chromosomes, the X or the Y, or if it's carried on one of the non-sex chromosomes, which are also called autosomes. Traits that are controlled by genes on the sex chromosomes are called sex-linked traits. Recessive sex-linked traits, for example, appear more frequently in males than in females, whereas dominant sex-linked traits appear more frequently in females. These patterns may become obvious only on inspection of a large pedigree. An example of how pedigrees can help determine how traits are inherited is given in the image that you now see on the screen. Anury is a condition seen in dogs and some other animals in which the animal has no tail. The pedigree reveals that anury is inherited as a recessive trait because unaffected parents can have offspring with the disorder. Can you determine the genotype of the individual labeled 1 in the image shown here on the screen? Why must that female be heterozygous, which is big A, little a, for anury? By the way, remember, an individual that carries one allele for a recessive trait and so does not exhibit the trait but can have offspring that do is referred to as a carrier of the trait. Must her mate have the same genotype? On the same pedigree, note that there are two individuals in the second row of the pedigree that have a puppy, indicated by question mark. Well, what's the probability that this puppy has anury? Go ahead and press pause on the video now and examine the pedigree carefully and see whether you can come up with an answer before I guide you to that answer in our next little segment. So go ahead, press pause now, see if you can figure out the answer. The question again is, what is the probability that the puppy indicated by the question mark has anury? Go for it. In the cross producing the mystery puppy, in other words, the parents of the mystery puppy, the father of the mystery puppy has anury, and so he must be homozygous recessive. And therefore, he will definitely pass on one little a to the son, to the puppy. The mother's genotype can be either big A, or heterozygous, which would be big A, or it could be little a, big A, given that both of her parents are heterozygous. Consequently, she has a 2/3 probability, or a 2 in 3 probability, of being a carrier of the little a allele, the recessive allele. So if she is, then there is a 50% chance that she will pass the allele on to her offspring, and he'll have anury. The probability, therefore, is 2/3 by half equals 1/3, or a 1 in 3 chance that the puppy will also have anury. Some traits may not show complete dominance, and many traits are also influenced by the environment. So it's not completely obvious always what a trait's mode of inheritance is. In such cases, the more individuals we can include in the pedigree, the more accurate the analysis. Some human pedigrees contain thousands of individuals and stretch back 6 or more generations. With some other species, it's possible to analyze tens of thousands of individuals per generation for a dozen or more generations. This is why plants and small insects, among other organisms, are excellent for studying inheritance patterns. Once we have an idea about how a trait is inherited, we can identify individuals who are carriers of a recessive trait and make informed predictions about a couple's risk of having a child with a particular disorder. This knowledge can be very useful in conjunction with prenatal testing and treatment.